How can you trust an AI or machine learning system? As more AI systems become prevalent and make decisions for humans, how do we know they are trustworthy? In this video, I'll talk about factors that contribute to the trustworthiness of a system using a simple example. First, hit the subscribe button and click on the bell icon to be notified of new videos on AI and architecture that I publish every other week. Say you apply for a loan with a bank and you get denied. A few decades back, this loan might have been denied by a banker who looked at your paper application. That's because the decision was based on a set of rules that the bank had set, and the banker was able to explain why your loan got denied. Maybe one rule was that you needed a steady source of income. Then, programmers built software applications into which these rules were coded. Since the bank gave the programmer the rules in the first place, the bank still knew how the software worked and could explain why your application was denied. Now, software applications are being replaced by machine learning systems. These systems are programmed differently. Instead of writing specific rules, data scientists feed the system data from previous years, and the system learns a pattern which is encoded in the form of a model. This model is used to make loan decisions. The problem is that this model can be complex and not easily interpretable to explain why your loan was denied. Let's look at the model a little more. First, machine learning is a branch of AI, which I explain in more detail in another video that you will find the link for below. Let's say the data scientists fed previous years of data for 1,000 applicants, and that data was the monthly income, and it included information as to whether the loan was approved or not. The system may learn a pattern that looked something like this. Essentially, the model generalizes the data to say that people who earned more than $1,000 a month are approved. But if the system had included the age of the applicant as well, then the system might learn a pattern that looks something like this. Using this model, you'll get an approval for your loan if you earn over $1,000 a month and are between the ages of 25 and 55. Even in this simple model, the decision boundary may not be clear-cut. In fact, the decision boundary that separates the approved from the denied applications may look something like this. So you see how the model gets complicated with just two attributes? If the data scientist has access to many additional attributes, like the applicant's gender, address, how many cars he owns, whether he rents or owns his house, the size of his family, his credit history, his utility payment history, his monthly medical expenses, etc., then you can see how it's beyond the human capacity to understand the model and be able to explain it. On top of that, some attributes have a stronger influence on the decision. For example, monthly income counts for more than the number of cars he owns. If such a complicated model was used to deny your loan, then it's a problem because the bank can't explain its decision and you can't really trust the system. What can the bank do so that the machine learning model can be certified at least by another third party like the financial government regulators? Here are a few things for the bank to think about while creating the machine learning model with the context of trying to understand and figure out why your loan was denied. Data quality. If the quality of data is bad, then the model is bad. Say, for many applicants in the past, the bank did not collect loan repayment history. It might then just substitute a low value in its place. You incorrectly got denied for a low repayment history score. Data bias. If the bank historically approved relatively more loans for men than women, then the system will think that gender was a factor, and it learns that pattern. You incorrectly got denied because you are a woman. Unnecessary complexity. A good model is built on a minimal set of attributes that make it most stable. If the data scientist, who may not understand the banking domain, includes meaningless data such as the weather, the system might find a pattern that people in the warmer weather places got approved more. Perhaps the bank has more branches in the south where the weather is warmer. So you incorrectly got denied because you live in a colder place. Explainability. If the model is complicated because it used a machine learning model that's called neural network or deep neural network, then it's hard to explain its behavior since humans can't easily interpret it. The bank might only be able to tell you that you got denied because Sam got denied, and your data resembles Sam's. Bob, on the other hand, got approved because he is similar to Chris, according to the model, and Chris got approved. You incorrectly got denied with no explainable reason. Right model fit. If the model is trained to make accurate predictions on the historical data itself, then it's possible that it overfitted and does not generalize well. If it generalizes too much, then it's called underfitting. You incorrectly got denied because the system did not learn the pattern properly. Essentially, you lose trust in the AI system because your loan was incorrectly denied. I just touched upon a few factors to consider when building trustworthy AI or ML systems. Sometimes trustworthy systems are important, and sometimes not so much. If the AI system is used to make medical diagnosis, then trust is extremely important. If it's used to make movie recommendations, then not so much. If you enjoyed watching this video, please subscribe and give me a thumbs up. If you'd like to hire me for consulting on how to deal with AI in your organization, send me a note through my website. Thanks for watching.